Well, hello there. I am Khairul and I will explain about the flowchart in the AQ system. Let me start. Okay, for the first step, start. Step 1, cylinder B extend. Okay, when the sensor B1 is activated, step 2, vacuum is on. Next, when sensor V is activated, step 3, cylinder B retract. Next, when sensor B0 is activated, cylinder A extend. Next, if sensor A1 is activated, step 5, cylinder B extend. Next, when sensor B1 is activated, step 6, vacuum is released. Vacuum off for 3 seconds. Continue. For step 7, cylinder B retract. When sensor B0 is activated, step 8, cylinder B extend. When sensor B1 activate, vacuum on. When V sensor is on, step 10, cylinder B retract. Next, if V0 sensor is activated, step 11, cylinder A retract. Next, if A0 sensor is activated, step 12, cylinder B extend. Next, for B1, when sensor B1 activate, step 13, vacuum is turned off. Vacuum plus off, timer for 3 seconds. Next, step 14, cylinder B retract. B plus off, and when B0 is activated, it will end. Okay, when all the 40 steps is finished, the step will be repeated from step 0 to step 14.
Insertion of all related input and output. For input, we use cylinder, vacuum, and push button. So when cylinder A retract, LED is our output. So LED A0 will light up. When cylinder A extend, LED A1 will light up. When cylinder B retract, LED B0 light up. Cylinder B extend, LED B1 light up. Vacuum on, LED V light up. And lastly, when PB is pressed, LED PB will light up. So all output is LED, where input is cylinder, vacuum, and push button.
There are a few modifications has to be made in our project. Firstly, if the suction cup is near the vacuum generator, less inner volume of the hose has to be evacuated compared to when the distance between cups and generator is greater, especially if multiple suction cups are supplied with vacuum. Secondly, small, lightweight membrane pumps, which are generally suitable for a vacuum application near the suction cup, can generate a maximum airflow of about 50% of 35 lpm at free flow. Thirdly, new applications using electrically driven vacuum generators, which were previously not possible. Such developments are leading to concerning energy efficiency and necessary airflow rates in standard applications. Lastly, vacuum suction cups with silencer reduces noise. However, they also influences performance because a silencer creates a flow resistance. there are few inputs and outputs involved in our project. The inputs are AO, which is cylinder A retract, A1 cylinder A extend, BO cylinder B retract, B1 cylinder B extend, V vacuum, and PB is for push button. As for the outputs, LEDs were used as indicators for the input.
Okay, for lab view block diagram and front panel, our title project BEE 3404 data acquisition and sensor is a system using NIDAQ, which replaced PLC controller SMC map 202 machine. From PLC graph set, the system flow step by step is converted and changed into lab view by using one push button which to turn on and turn off the system. 3 output lamp is used as a cylinder A, cylinder B and vacuum, so that we can know the cylinder moving by looking at the lamp for easier monitoring. If the lamp turn on or in high state, that means the cylinder or vacuum is moving or being turned on. Next, 5 sensor is used and labeled as A0, A1, B0 and B1 and V. Then, LabVIEW software is used to draw the sequence movement of the map 202. The stack sequence structure is used as the main of the flow program instead of key structure. A stack sequence consists of one or more sub-diagram or frame which can execute sequentially, step by step. The structure border is added to create frame or sequence local to pass data between frame to frame. As I said before, push button is used and 3 LED is used and indicate cylinder A, cylinder B and vacuum. And 5 cylinder by using LED is used to indicate sensor for in the front panel. Okay, for step 1, the cylinder B is extend and turn on and the sensor at B1 is also turned on. For the next step 2, which cylinder B and vacuum is turned on and sensor at B1 and V also turned on. For step 3, vacuum is turned on while cylinder B retract, hence sensor at B0 and V is also turned on. Next, for step 4, which cylinder A extend and vacuum is turned on, sensor at B0 and V also is turned on. For step 5, which cylinder B extend, cylinder A and vacuum is turned on and sensor at A1, B1 and V is also turned on. For step 6, vacuum is released, cylinder A and cylinder B is turned on and sensor at A1, B1 also is turned on. For step 7, cylinder B is retracted, cylinder A is turned on, hence sensor at A1 also is turned on. For step 8, cylinder B extend, cylinder A is turned on, hence sensor at A1 and B1 is turned on. Next, for step 9, which vacuum is turned on, cylinder B and cylinder A also turned on, hence sensor at A1, B1 and V is also turned on. Next, step 10, cylinder B retract, cylinder A is turned on, hence sensor at A1 and V is also turned on. For step 11, cylinder A is retract, cylinder A and B is turned on, hence only sensor at V is turned on. For step 12, cylinder B extend, vacuum is turned on and cylinder A is turned off, hence only sensor at B1 and V is turned on. For step 13, vacuum is turned off, cylinder B is turned on, cylinder A is turned off, hence only sensor B1 turned on. Step 14, cylinder B retract back, cylinder A and B is turned off, hence all sensor is turned off.